Okay, so how'd that question go? It said, election is held, blah, blah, blah. A gets a majority. So here's the quiz. Question. A gets, did it say majority? Yeah, majority. A gets a majority of the first place, votes, but B wins. Which of the following methods could have been used? So, which methods used? So, and it says pairwise comparisons. Was A. B was board account. C is plurality with elimination. D is all. E is none. Okay. All right, so it's all, this one is all about your handout I gave you. Do you all have that handout? Does anybody need another one of those chapter 1 handouts? So on the handout, if you look at that little box, and again, I put this on your 3x5 card for the real test on Monday. So looking at that thing, first off, what does this even mean? They're going on and on, blah, blah, blah. A gets a majority, but B wins. What does that mean when A gets a majority, but B wins? What has happened? These mean violation of the majority criterion. First off, do you realize that's what it's saying? Right? Because if somebody gets more than half of the first place, they should win, shouldn't they? That's our sense of fairness. Remember these 4 senses of fairness? You want to kind of recognize those, right? So one of them is if anybody gets more than half of the first place, whatever method, they should be the winner. If more than half of the crowd thinks they're the best, right? In a presidential election, you win automatically, right? It's been a long time since we've had somebody have more than half, hasn't it? Way back, maybe till President Clinton. I'm guessing that's the last time. Anyway, right? Everybody always wins with just under half, it seems like. But anyway, so if you have more than half, you for sure should be the winner, right? If you have more than half of the first place, then you for sure should be the winner. But, so if you're not, like if B wins, somebody other than you and A has more than half of the first place, but somebody else wins, that's a violation of our sense of fairness. That's a violation of the majority criterion, right? So you want to kind of recognize these. They're going to give these to you. Anyway, so what? So that's a violation of the majority criterion. Well, then if you look down at the table, which ones violate the majority criterion? Board account. See how board account has it listed in its table to the right? Violates majority criterion. See in the table, second, all the way to the right? I'm going to put it up here in the overhead. Everybody see where that is? Hello, there it is. Oof. So there it is, right here. Violates majority criterion, board account. So that's why you want to put that table on your 3x5 card for the exam, well, for the practice exam tomorrow, for the real exam on Monday especially. Okay, so therefore, it's board account. Questions on that? Does that make sense? How to determine that kind of thing? Be able to do that when it counts for the big points? All right, let's dive in. All right, good. Jasmine Rivers? Is Jasmine Rivers? No? Not here? Okay. All right, so it's, everybody, I don't know, I haven't checked, but I'll check tonight on the Math Excel system and the clickers, right? I need to drop if you're not on. So make sure you've purchased Math Excel and you've purchased the clicker and you're in line with everything, right? That is a requirement of the course. That's participation in the course. So make sure you've done that, or I'll be looking at the drops for that if you don't have that. All right, so let's dive forward. So looking at the voting system, remember how it works. Remember that the, let me make it a little bigger here for us. And that first number, what's that first number called? Anybody remember that? Quota, yeah. It's the quota. It's the, and what is the quota? What does that mean, the quota? 6, yeah.
How much they
How much they need? Yeah, well said. How much they need, to pass anything or do whatever it is they're doing in their little weighted voting system. So chapter 1 was voting individually and what fair ways are to determine the will of the people. And now chapter 2 is about weighted voting systems. And what we're looking at in weighted voting systems is how to determine the real balance of power. Because this is very, very needed actually in real life. There's all kinds of systems of weighted voting. And people in those systems want to know how much real power do I have or not have. They want to know, and it's not always obvious. All right, so and these 4 numbers are what we call the players. You know, player 1, player 2, player 3, player 4, the different participants in the system. Okay, so determine which players, if any, are dictators. Now, what does that mean? I think you know, without me being too formal. What's a dictator? That's a silly question, huh? Absolute power, right? Of course. Absolute power. No fooling around at all, right? I'm listening to Winston Churchill's biography. Like I said, I'm a wannabe history teacher. So as I drive around, I'm listening to Winston Churchill's biography. All those times during World War II I think are very interesting. Anyway, he went and visited the dictator of the time, even more than Hitler, was Stalin, right? He absolutely ruled Russia with an iron fist. In fact, at one point when a group was invading his oil fields, he went over to the head army guy of the oil field, Stalin did, this is recorded in history, and he pointed his fingers like a gun, Stalin did. Imagine one of our elected officials doing this. It's just funny, the difference. Stalin points his fingers at the guy that's the head of the army protecting the oil fields from the invading Nazis. And he points his finger and says, if they get in and get the oil fields, we will shoot you dead. Then we will pull you up and shoot you again. And he actually did his fingers. You imagine like any elected official doing that? You know, I mean, we'd be like, you're a nut. It would not, anyway, but Stalin just did whatever he wanted to do. He was a dictator. All right, so dictator, they do whatever they want to do. So what that means is they can pass something alone or they can remove something. They can do whatever they want. All right, so how do you know if somebody's a dictator? Well, to be a dictator, they must have the quota or more, They got to have enough to do the quota all by themselves. That's what a dictator does. Doesn't need anybody else to combine with him or her. He or she alone can make things happen. Nobody's a dictator, right? Because 17, 13, 6, and 2 they're all under 28. So no dictators here. So there's no dictators in this system, right? Does that make sense? If like this first number was 29 or something, then that first player would be a dictator. But that's not the case. So those are easy to spot. Nothing confusing there. We have no dictators in this system. Let's go on. Question 2 is going to ask, does anybody have veto power? Can I flash off that? You all got that down? I'll flash to the next screen here. So on the next one, does anybody have veto power? Now, you guys know veto power, right? The president has veto power, right? What does veto power mean you can do? You can decline, right? Power to block a law, but not power to pass a law alone. This is all about alone. So power to block a law alone, like all by yourself, right? So if all of Congress votes on something, passes it, likes the law, and it comes to the president has the ability to say, nope, veto. Now, of course, they can override him with 2/3 of the... But anyway, just that aside, just keep it simple. Veto just means the ability to say no. That's different than dictator. He can't pass anything alone, right? The president can't think up some new law he likes and say, I'm just going to make this happen. He can't positively make something happen, but he can negatively block anything he doesn't like, right? That's veto power. See the difference between veto and dictator? Veto's got like half the power of a dictator. They can negatively block things, but they cannot positively block anything they want. So alone, that means the person alone can veto, can block. Okay, so, well, how do you know? Let's take a look at these numbers. 28, 17, 13, 8, 2. Let's start with the most powerful player. Let's start with the 17. Can the 17 block something alone? If the 17 says no, and everybody else says yes to some law, that would be veto power, right? If you say no, but everybody else says yes, does it get blocked? Yeah? Did everybody see how we know that gets blocked? Well, because how much do they have without him? 13 plus 8 plus 2, it's a 3 there, is, what's it, 23 votes without player 1. So they have only 23 votes without player 1. Not enough to pass. That's not enough to pass because it takes 28, in this setup anyway, to pass anything. That's the quota. Not enough to pass, so P1 vetoes. Right? P1, if he says no thanks, they can't get it done without him. Anything he says no to will be no. He does have veto power, doesn't he? Do you all see that? He can't pass anything he wants. He needs other people. Like if he really likes something, he needs somebody else to join him in liking it. But if he doesn't, like wants to block anything, he alone can block by just saying no. So player 1 has veto power. How about player 2? Can we now try player 2? So 17, 13, 8, 2. So if player 2 says no and everybody else says yes, can player 2 block things? How much do they have without player 2? 17, 8, and 2. What's that? 27. Is that enough to pass? Not quite. You need 28, huh? So, player 2 veto also. So player 1 and player 2 both have veto power in this system. Either one of those two can say no, and the thing's not going to get passed, huh? It's kind of weird, huh, having had 2 vetoers. But that's how this system would work. Does everybody see how I did that? I just, whenever you want to check veto, you just have them say no and everybody else say yes and add them up. If everybody else doesn't have enough, then player 2 blocked it, right? Vetoed it. So player 2 does have the ability to say no alone, and it blocks anything he doesn't like. Again, he's not a dictator. He can't pass anything he wants, but he can block anything he doesn't like. How about player 3? Player 3 is not going to have it, huh? So I'll come up here for player 3, 28. 17, 13, 8, and 2. So what if player 3 says no, but everybody else says yes? Do they have enough? 17, 13, and 2, 32. That's enough. That's more than 28. No player 3 veto. No player 3 veto. Player 3 cannot veto, right? Just because player 3 doesn't like something, it still might pass if everybody else likes it. So player 3 does not have the ability alone to block things. He doesn't have veto power. Are we good? And now, if player 3 doesn't have veto power, how could player 4, who's got even less power? So as soon as you get to a no veto power, everybody below that's got no veto power, right? Does that make sense? So player 3 and player 4 both have no veto power. So who has veto power? Player 1 and player 2. There's our answer. Feel like you could do that on the exam? Does that make sense how I did that? Just have them say no, everybody else say yes, and add them up. Questions on that? All right. Okay, so now part 3 says, who are the dummies? Are any of these players dummies? What's a dummy? Someone with zero power that really shouldn't even show up at the meetings, because whether they say yes or they say no, it affects no vote, no final result in any way. That's a dummy, right? No actual power, no power. Now, how do you know? How do you know? Well, start with the smallest guy. I mean, if it's anybody, it's going to be the 2, right? You're not going to, obviously, 17's not a dummy, right? But start with the 2. Maybe, I don't know, I really don't know right now. Maybe the 2's a dummy. How do you determine it? Well, you try to find, you ask yourself, when can the 2 change the vote, or the result, let's say the result from no to yes. Because that's what it means, right? If you can never do that, then you don't have any power, right? If you can never change the result, then you don't have any real power. So is there ever a situation where the 2 could change the result? Well, let's take one more step logically. So this was for 2 to change the result. What would have to happen? Well, you need 28 to pass anything, right? You would need 26 or 27 total without the 2. You with me? You would need to have a total of 26 or 27 without the 2. Then the 2 joins, and it hits 28 or 29 and passes. Right? That'd be the only way. Do you see how I came up with that? I just took the total. How did I come up with this 26, 27 magic thing? I just took 28 and subtracted 2 and got 26. Right? I said, well, for the 2 to make the difference, you'd have to have a total that's at 26 or 27. So you go from there, and then you go up to 27, because you can't go to 28. That would be passing already. Am I making any sense? In other words, if you're at 26 or 27 already, you're not passing, right? You're not 28. And then 2 jumps in, it puts it over the line for passing. Do you see how those are the only 2 totals? And so now we're going to look at the other numbers and say, hey, is there any way to get 26 or 27? Am I making any sense? Want me to talk a little bit more about that? You guys don't look totally happy about that. For example, what if the total was 25 and then 2 jumped in and said, I'll help? Well, that's only 27. Still not going to pass. 2 is not making a difference in the result if he jumps onto a 25 bandwagon, right? Or if he jumps onto a 24 bandwagon, he only brings it up to 26. He still did not make a difference, right? He exercised no real power. So the only times in which the 2 is going to exercise any real power is if the total was 26 or 27, because then he'll add 2 to those and bring them from not passing, below 28, to 28 or more, passing, won't he? He'll bring them to 28 if you add 2 to the 26, or 29 if you add 2 to the 27. He'll bring them to passing. So that says to us, okay, is there a way without the 2, right? We're talking about without the 2. Skip him, because he's going to jump on at the last minute. Is there a way without the 2 to have a total of 26 or 27? I don't know. What's 17 and 13 make? 30. They're already passing. They don't need the 2. So that's not it. What does 17 and 6 make? 23. That's not passing. If 2 joins that, it's only 25. It's still not passing. 2 did not make a difference there, right? What about the bottom 2, 13 and 6? It's only 19. That's not passing. If 2 joins that, it's 21. It's still not passing. He didn't make a difference. No is the answer. There's never a way to have 26 or 27 before the 2 jumps on. So there's never a time where 2 will make a difference. 2's a dummy. No power at all. 0 power. Even though he's got 2 votes, whatever, it's no power. It's 0 power. He might as well not show up at the meetings. That makes sense? Do you see how I determined that? I just played around with the numbers. I really have no magic, like plug in the X and, I have no magic formula. You just have to kind of play with the numbers. It just depends on the system. So I just looked at it and I thought, well, is there ever a time when 2 will make a difference? We'll take the vote from below 28 up to 28 or more. That's making a difference. If you never do that, then you have no real power. You're never making a difference. You might as well not come to the meetings. Your vote doesn't affect anything in the end. Is that good? Because there's never a way to get 26 or 27. So 2's a dummy. Now how about 6? So we got 2's a dummy. Let's go to a fresh screen and ask ourselves, because maybe sometimes there's more than one dummy, just like there was more than one veto person, right? So maybe there's more than one dummy. Is the 6 also a dummy? I'll let you think about that. Is 6 a dummy? So we already know that 2 is a dummy. Is 6 also a dummy? So let me give you a second. I think you'll get more out of it. You saw me reason it out. So try it on your own paper for just 30 seconds. I'll give you 30 seconds. Think about what that means. What total would you have to have for 6 to make a difference? Okay, so what total would you have to have for 6 to make a difference? If you want to hit 28, subtract 6, 22, anything in the neighborhood of 22 to 27. Does that make sense? Because if you're anything in the neighborhood of 22 to 27, why do I go up to 27? Because that's the lowest number that doesn't pass. Bless you. Does that make sense? 22, add 6, and he'd make it pass at 28. Or anything, 23 or 24, 25, 26, or 27. Any of those numbers, if we have that total and then add 6, it goes from not passing to passing. All right? Does that make sense? If we have this, can we have this total without the 6? So is there a way to have that total without the 6? Then the 6 will jump on and make a difference. Take it from not passing, right? Because all of these numbers are not, it will not pass, and then add 6, and then all these add 6 to this, it'll be somewhere 28 to whatever, 33, it'll be passing. Right? So take these numbers, add 6, and they all go from not passing to passing. So is there any way to have this total anywhere in that region without the 6? I don't think so. I'm just looking. 17 and 2, that's 19. That's not anywhere in the 22 to 27 zone. That makes sense? If 19 and 2, or 17 and 2 get together, they have 19. Will adding 6 help that? No, that'll only bring it to 25. It still won't pass. It still won't be 28. So 6 is making no difference if he joins that group. We call that a coalition, by the way. I'll start using the terminology. Coalition is just a group. So if you have a coalition, a group that involves the 17 and the 2, 19 and 6 says, I'll join. That coalition goes up to 25, but they are a losing coalition. They will not pass. They don't have enough to make it pass. They're only at 25. So that's not going to work. Now you think, well, yeah, 17 and 13, well, they got 30. They don't need anybody. 6 doesn't help them. They're already passing. He doesn't make a difference, right? That's why it's got to be 22 to 27. That's where not passing, add 6, passing, right? So I don't think so, right? Can you see any way to get a total 22 to 27 without using the 6? Right? Without the 6? No, I don't think so. So I did 17 and 2, 13 and 2 is only 15. No, 6 is a dummy also. 6 never makes it. It's kind of surprising, huh? You wouldn't think that at first. But 6 is an absolute dummy. Just don't even bother to come to the meetings. Even though you got 6 votes and you think you have more power than the 2, you don't. Not really. You've got no power. You're a complete dummy in the system. There's never a time where 6 makes a difference. Does everybody see that? You get the way we think, because this is the kind of thing they're going to ask you a lot about. Did you get that idea? Did you get that logic I'm going through to arrive at that conclusion? There's never, you'd have to have the 22 to 20. How did I get that range? I took the total minus 6. Because that's when 6 could make the difference, right? 22, add 6, he makes the difference. All the way up to 27, because it's still losing up to 27, add 6, he'll make a difference, right? But there's never a total 22 to 27 without the 6. Is there? There never is. I tried the combo, 17 and 2, 13 and 2. No. All right, so now, well, okay, so 2 is a dummy, 6 is a dummy. How about 13? Now, we already know 13's got veto power. So how could 13 be a dummy? He cannot be. But let me go through the formalities with you anyway. So right now, we know we've got this set up. 28, 17, 13, 6, and 2. We got this one, dummy, dummy. Both those are dummies, right? 6 and 2 are both dummies. Now, how about the 13? Is he a dummy? Well, let's do the same logic. What do? 28 subtract 13, get 15, right? 15's when the 13 would make a difference, right? Take 15, add 13, brings it to 28. Takes it from not passing to passing, right? All the way up to 27. Remember, you always go up to one shy of passing. Why? Because all that's the range of losing. That's the losing range. That's the losing range by which adding 13 will make it win, right? If you're anywhere in the zone, 15 to 27 votes. If any group has 15 to 27 votes, and then the 13 jumps in, he'll take them from not passing to passing. He'll make a crucial difference, won't he? Does he ever do that? Is there a way to get any numbers for 13 in the zone between 15 and 27? Absolutely. Are you good? 17 and 2, for example. That's 19. Yeah. So 17 and 2 are like, hey, we like this thing. We like this thing. And 6 is like, no, I don't like it. Yeah, 2 and 17 are like, yes, we like it. And 13's looking at it going, what do I think? They have 19 votes right now. They're not passing. And 13 says, all right, I'm going to jump in. If he jumps in, yeah, they're in. They're over 28. Right? If he says, nope, I don't like it, then they're not passing. He makes a difference. He's not a dummy. His opinion. There are situations in which his vote will matter. Not every situation. So that's not what it means to be, right? You're a dummy if you never, can ever make a difference, right? That's what it means to be a dummy. He would make a difference in this situation, for example, or the 17 and 6. Right? Because they're both in the zone 15 to 27, right? 17 and 2 is 19. That's between 15 and 27. 17 and 6 is 23. That's between 15 and 27. Yeah, there are several ways in which the 13 could make a difference. He's not a dummy. Which we already knew because he's got veto power. But anyway, I just wanted to double check. See how the reasoning works? Does that make sense? So we got 2 dummies. So what's the answer? Well, we're done. Yeah, so 6 and 2 are the dummies. And 17 and 13 have veto power, don't they? You can have none. You can have no veto power and not be a dummy. You know, there's all kinds of things that can go on. All right, is that good? There? Okay, so question 8. What is the weight of the coalition? Just means group. Coalition formed by P1 and P3. So we have this 12 quota and 10, 7, 4, 1. So this is player 1, player 2, player 3, player 4. Player 1, 2, 3, 4, just like that. So what is the weight, they're asking me, of the coalition formed by P1 and P3? So P1, P3, 10 plus 4, 14. Good so far? So that's all they want you to. So the weight of the coalition just means total number of votes for that group. That's all that means. P1 and P3 is 14. All right. B. Write down all winning coalitions. That's a little tricky. All winning coalitions. All winning groups. How do we write down all winning coalitions? Well, let's fix that. Let's go through every combo that can do that. So let me just try it out. So I'm going to do part B here. All winning groups or coalitions, same thing. All winning groups. So I want to take these 4 players, P1, 2, 3, and 4, and list all ways that they can win. What does win mean? they have to hit the quota of 12 or more, right? So here we go. First off, I'm going to list 4 players. Then I'm going to list all of them with 3 players. Then I'm going to list all of them with 2 players. Then I'm going to list all of them with 1 player. There'll be none with 1 player. All right, here we go. So how many groups are there with 4 players? Well, there's only one group. It's just all 4 of them. There's only 4 total. If all 4 of them, 10, 7, 4, and 1, like something, vote for something, are in favor of something, certainly it passes. They have more than 12 votes, right? 12 or more votes. Okay, let's go on. Let's list all the 3-player. Let me do all the 3-player teams now. Okay, so what are all the 3-player teams? Well, you know what you want to do on this, guys, is one of the skills that you need to have for this book is to be able to list things kind of in a system. Do you know what I mean? Because you have to have a way where you just don't miss any of them. If you miss even one, it can really mess you up. So how do you list? So I want to take those 4 players and I want to list every group of 3. I want to list every group of 3. And I can't miss any. I can't just list a couple of them and kind of hope I have them all. And the way to not miss it, the way to be sure, is to do it with a system rather than kind of randomly. So what do I mean with a system? Well, the easiest way is just to, if you're going to form 3 players out of 4, that means you're going to leave 1 out every time, huh? So for example, I could start at the bottom, leave out the 1. Okay, that would be 10, 7, 4. That's a group of 3, leaving out the bottom 1. Next group, leave out the 4. 10, 7, 1. That's a group of 3. I left out the 4. Now, leave out the 7. 10, 4, 1. Next, leave out the 10. 7, 4, 1. I know I've got them all, huh? Because I used a system. See how that's every possible. Now, they're not all winners. I'm going to fix that in a second. But first off, I just wanted to list them. That's every possible group of 3. I know I haven't missed any because I used a system. What was my system? Just leaving 1 out every time, right? I just left out the last guy, then left out the 1, left out the 4, left out the 7, left out the 10. Whenever you have a group of 3, that means you're leaving 1 out. So those are them. Now, are those all winners? Are all those groups going to win? What does win mean? They have 12 or more, right? They get their way. They get their vote successfully. Do they all have 12 or more? Yeah, I guess they do, huh? Even the lowest one here has exactly 12, doesn't it? Even the lowest one. So yeah, so that's a go. They all do have exactly 12. We've lost contact. Come on back. There. Yeah, so even the bottom one has 12, right? So that has 12. They all have 12 or more. So they all are winning groups, aren't they? So let's go on now. Let's list all of them with 2 players. Let's list all the groups that are winners that have 2 players. Okay, now remember, they got to have 12 or more, right, to win. So what could they be? You could be 10 and 7. You could be 10 and 4, because that's 12 or more. That's it, huh? Do you see how that's the only groups of 2 players that are going to have 12 or more? Right? I just took the 10 with the 7 and the 10 with the 4. 10 and 1 would only be 11. It's not going to make it. 7 and 4 would only be 11. So these are the only groups of 2 that have 12 or more. Those are the only winning teams with 2 players. And there's no 1-player winning team, right? That would be a dictator. So there we go. There's all the winning combos. Everybody see that? Now, the book is going to list it differently. So let me show you what the book's going to do. The book's going to go player 1, player 2, player 3, player 4. I wish they wouldn't do that. It's kind of confusing, but they do. They're going to go player 1, 2, 3, 4. Instead of saying their numbers, they're just going to reference them as those individual players. And then it's going to do the same thing when it lists these guys and when it lists these guys. So you got to kind of recognize which ones it's talking about on that. Let me show you. Are we okay with that? I'll go back and I'll show you. Okay, so looking back here. So what answer did we get? We got this is our answer. These are all the winning teams, right? Let's try to look at the two-player. What is this? This is player 1 and player 2, player 1 and player 3. Those are the only two-player winning teams, huh? Player 1, player 2, player 1, player 3. Let's look back and see which of those have that. Player 1 and 2, 1 and 3. That looks right so far. B is not it. See, they go 1, 2, and 1, 4. That's not right. So B is out. Everybody see how I've already eliminated B? This is exactly what you're going to want to do on the multiple choice test. It'll look just like this. So that makes sense how I've eliminated B. They said 1 and 4. Remember, that's not the case. If you look back, it's 1 and 2, 1 and 3 are the only two-player winning teams. So it's not 1 and 4. B's out. A looks good so far. Let's keep going. What about C? 1 and 2, 1 and 3. Yeah, C looks good so far. How about D? 1 and 2, 1 and 4. No, D's out. All right, I'm down to 2 options. So far, so good. Now we got to look at the. We got to look at the others. How many? I don't know. You can do whatever you want. How many total are there? How about that? There's 1, 2, 3, 4, 5, 6, 7. 7 different teams total that win. How about we do it that way? 7. So how many does this have? 1 team, 2, 1, 2, 3 teams, 4 teams, 5 teams, 6 teams. So yeah, it's got to be A. Because B's already out, and C only has 6 winning teams. Something's missing on C. I don't know what is, but something is. So the answer must be A. See how I determined that? So do stuff like that, to help yourself out in the multiple choice test. Kind of working through those options like that. Is that good? Questions on that? So found all the winning teams? All right. Now there's more. We're not done with this question. So we found all the winning teams. Now they're going to go on to question C. So let's go there. Okay, so question C. Which players are critical in the coalition P1, P2, P3? Now, let me write that out. So P1, P2, P3. Remember the original system here is 12, 10, 7, 4, 1. This is player 1, player 2, player 3, player 4. All right, so in the player 1, player 2, player 3, you're talking 10, 7, 4, right? Let me write that a little better. So 10, 7, 4. All right, who's critical? How do you determine that? How do you determine who's critical? Here we are right here. This is the hub of the whole thing. This is the most important thing we've done right now, is when we determine who's critical. What does it mean to be critical on a team? Doesn't it mean that if you don't show up, the team loses? Right? Isn't that critical? We had my son played a lot of Little League Baseball, and one year, 2 or 3 years ago, he was on a team. I went to the first practice, Little Leaguers. He was 11 then. So most kids were 11 and 12. And I went to the first practice. I was helping the coach. I wasn't the coach. I was just helping and catching balls. And this one kid came about halfway through practice, taller than the other adult coach. I thought he was another coach at first. Anthony, super tall. Not only tall, when they hit the balls to him, he fielded them like a major leaguer. I mean, it is awesome. And I remember coming home going, this kid's a player, and he's a giant, and he's highly skilled. And he did. In fact, he's playing high school ball in our area now. As a freshman, he's already on the varsity team, and he's a phenom. Anyway, so 3 years ago, he was on my son's Little League team, Anthony. You know what happened when Anthony came to our... Now, Anthony didn't always come to our games because he was a very popular baseball player. He played on a travel team, he played on a junior high team, and he played on our Little League team. So he was very busy, and sometimes he wouldn't always make it to our games because he was at other games and stuff, right? He was actually given an award when he graduated junior high by the local Clovis High, one of the high schools, awarded him as the top junior player in the area. So he was a phenom, right? So when he came to our games, we'd always be waiting right before the games. We'd be looking out. Is Anthony going to make it to the game? Because if Anthony made it to the game, we won. He put him on the mound, and he would just shut them down, right? They were like kids playing with an adult, right? And if Anthony didn't make it, we often, like half and half maybe. But yeah, so Anthony was critical. Anthony was critical. Critical means if you don't come, they lose. So I'm exaggerating. We've won sometimes without him, but not very often. So Anthony was critical. Critical means if you don't come, they lose. You have to be there. You're absolutely necessary. Critical, right? Critical. So ask yourself, they're asking, say, which of these three are critical? Well, in other words, they're saying critical. Let me watch, right, what critical. Critical means if you drop out, if you don't come, you drop out, the team loses. That's what it means to be critical. All right, well, let's start down here. If the 4 drops out, does the team lose? Well, how many votes do they have without the 4? 10 and 7. 17. Is that enough to pass? Yeah, all they need is 12. So they're like, hey, 4, we like you, but you're not critical. If you don't show up, we're still going to win. Right? Don't need the 4. All right, so let's keep going. So the 4 is not, we'll say no, not critical. Everybody follow that? If the 4 doesn't come, they can still win anyway. So he's not absolutely necessary. We don't have to have him. He's not critical. Right? All right, now let's say, what about 7? If the 7 doesn't come, do we still win? Yeah, 10 and 4. That's enough, 14 or more. So they're like, nah, 7, you're not critical either. If you don't come, we still win anyway, so you don't have to have the 7. He's not critical. Making sense? And now finally, 10, 7, 4. What if the 10 doesn't come? Oops. So if the 10 doesn't come, do they win without him? No, they've only got 11, which is not 12. So they lose. But if he comes, they got plenty, right? 10 and 7 and 4, it's way over 12. So he's critical. So 10, player 1, is the only critical member of that team. Sometimes there's a couple of them that are critical. Sometimes there's only one. Sometimes there's none. You know, so player 1, on that team anyway, is the only critical member. He's got to be there. If he drops out, they lose. He's absolutely critical. Player 1. All right, so that's option D. Does that make sense? We good there? All right. So we'll move right along. So, and then question D is going to be the big one. So they're going to ask us to find the Bahnhof power distribution of the weighted voting system. Okay. So we're going to do this for like a whole kind of thing here. So I don't want all that in the way. So let me do this actually. Let me do this. I'll do one of these back screens. Yeah, that one. Good. All right. So okay. So here we go. So what we want to do now is the final question. I'm on D now. The final question: find the Bahnhof power distribution. Oh, in fact, let's find the actual power. So this will be the first one where we actually find the power. Like I want to know percentages. Like what percent of the power does that 10 have? What percent of the power does that 7 have? It's not simple. You can't just divide it by the number or something like that. You've got to actually look at times they exercise real power. So here we go. So here's how you find. We've been kind of like building up, but this is really our goal, is to find what's called the Bahnhof power distribution. So here we go. Start with the 12, 10, 7, 4, 1. Okay, you start by list all winning coalitions, which we already did, right? All the winning groups. Remember what they were? We had the 4-player group, which is everybody. 10, 7, 4, 1. Then we had some 3-players groups, didn't we? And let me just list those again. Remember how we listed the 3-player groups? We dropped 1 out per time. We dropped out the 1 and said 10, 7, 4. Then we dropped out the 4, said 10, 7, 1. Then we dropped out the 7, said 10, 4, 1. And then we dropped out the 10, said 7, 4, 1. Right? And those were all winners, weren't they? You with me so far? Those are all winning 3-player combos. And then we listed the 2-player combos, and there was only 2 of them that were winners. 10 and 7 and 10 and 4. Those are the only ones that have 12 or more. Okay, so back to where we were. You list all the winning combos. There's all the winning combos. And then what you do is you go through and you circle everybody that's critical on every team. Because you only have real power if you're critical. Does that make sense? You only make a difference if you only make a difference if you make a difference. You only have real power if you're making a difference. Okay, so here we go. Let's start with the 2-player teams. These are all winning teams, aren't they? All these teams are going to win. They're going to get the vote they want, right? Like this team is 17 right now, aren't they? Which is more than 12. So boom, they win. If 10 and 17 like some law or whatever, they can get it past 12 or more. Just the 2 of them. They're going to win. They're going to get their way. But what if the 10 drops off the team? Says, I changed my mind. I don't like that law anymore. Can 7 alone pass the law? Well, of course not. He's only got 7. Which means what? The 10 is critical. I'll underline it. You underline them, circle them, however, whatever method you want, to say they're critical. So, or maybe I'll just circle it. 10 is critical. How about the 7? I'm kind of making a mess out of this thing. Let me get rid of all that. How about the next one? How about the 7? What was it? 10 and 7. What if the, so the 10 was critical. What if the 7 says, I changed my mind. Can the 10 alone pass the bill? Well, no. So in this little team, they're both critical. Y'all understand it? It depends what team you're on. It depends what team you're on, whether you're critical or not. Right? Because you might think, wait a minute, a minute ago we said 7 wasn't critical. Well, on that team, right? It depends on what team you're on, doesn't it? Right? My son wasn't critical on the Anthony team. It didn't really matter whether he showed up or not. Not a lot. But the next year, he actually played on a little bitty tiny team. He actually qualified for the lower league, which was kind of sad at first, but then he was a big hero. He was kind of in the middle, and they put him up and they put him down. So he went down just barely. So he was a big hero on a lower team. He played shortstop and batted fourth. He was a big hero on a lower team. He was kind of critical all of a sudden. So it depends what team you're on. You get the idea? It isn't like 10 is always critical or 7's. It depends on the team, right? So look at this team. Here's a winning team here, right? 14 or more. But if the 10 doesn't show up, they've only got 4. They lose. And if the 4 doesn't show up, they've only got 10. They lose. So both those guys are critical. On a 2-man team, almost everybody's critical, right? Let's go to the 3-man teams. Here, how about on this 3-man team? Let's start on this one up here. If 10 doesn't show up, 7 and 4 is only 11. They don't have 12. They lose. So 10's critical. You with me? How about the 7? Is he critical on that team? No. Because if 7 doesn't show up, they still have 10 and 4. We're just doing these one at a time, right? We're just saying if one guy doesn't show up, one at a time. So if that 7, just that 7 doesn't show up and they only have 10 and 4, that's still enough. That's 14. They don't lose. So 7 is not critical. 7 is not critical on that team. Right? Is that making sense? And if 7's not critical, I don't even need to look at 4. 4's not going to be critical on that team. Right? You with me? So 10 was critical, but 7 on this team, but 7 and 4 are not on that team. Right? If 7 doesn't show up, they still got 14. 4 doesn't show up, they still got even more, 17. They got plenty to get it done. 7 and 4 are not critical. They cannot come. Just one of them. Not, if they both, but we're just talking one at a time. We're talking if one player doesn't show up. If 7 doesn't show up, it's still okay. They have 14. So in this team, the only critical one is 10. Right? The 2-man teams, everybody was critical. You had to have them both. You're going to lose. Right? Let's do the next one. If 10 doesn't show up on this team, do they lose? Yeah, they only have 8. They're going to lose for sure. Right? Can you take it from there? I think you'll get more of it rather than me just talking you through it. So let me give you about 1 minute Try the rest of these. So ask yourself one at a time, just cover up, say, if he doesn't come, do they lose? 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 That's always the question. You're critical if they lose without you. If you don't come, and then they lose. You guys doing okay? Let me jump in with you. So I'm going to go down the line. I'm going to start with the 7 right here. If we, maybe I'll underline him as I look at him. So that's 7. Is this 7 right here critical? Well, if he drops out, they only have 11. So he's important, right? They lose without him, right? If this 1 drops out, no, they're still okay. They got 17. He's not critical, right? Good there so far? Is that making sense? Next team. If the 10 drops out, yeah, they've only got 5. They're certainly losing. 10's critical. Okay, if the 4 drops out, they've only got 10 and 1. They've only got 11 without the 4. They lose. So 4's critical there, huh? If the 1 drops out, now they got 14. They got enough. They're okay. 1's not critical. Next one. 7 drops out. Yeah, they've only got 5 without him, so they're going to lose. If 4 drops out, yeah, they've only got 8, 7 and 1, 8 without him, they're going to lose. 4's critical on that team. 1 drops out. Yeah, 1's critical there, huh? They've only got 11 without the 1. The 1's no dummy, that means. The 1 is making a difference here, isn't he? Right? If 7 and 4 like something, they get 11 votes. If 1 says, I like it too, they win. If 1 says, I don't, they lose. That's called real power. 1 has real power right there. Do you see how if you're never critical, then you don't really have any power? Does that make sense? If there's never a situation in which your presence matters on the outcome, then really you've got no power. If you're never critical. That's real power, isn't it? That's exercise, making a real difference. Does that make sense on that? It really matters that way. All right, let's keep going. So, 10, 7, 4, and 1. So let's go through it. If 10 doesn't show up, they've got 7, 4, and 1. Do they win still? Yeah, because that's 12. So 10 is not critical on that team, right? If he doesn't show up, they're still okay. If 10's not critical, how could anybody less than him be critical? So nobody's critical on that team. Does that make sense? As you're going down the line, as soon as you've got one that's not critical, the rest below it can't be critical either. Right? If you're not critical, how can lower numbers be more critical? They couldn't be. Does that make sense? So nobody's critical on that big 4-player team. Because that's a big, strong team, right? They don't need all those people, right? The weaker teams, everybody's critical, huh? Does that make sense? And then the in-between, some are, some aren't. All right, so now what does all this have to do with anything? Well, every time we've circled something, real power was exercised. Don't you agree? I mean, I'm just trying to appeal to you reasonably, right? Math is just, logic played out. So, right, I mean, isn't that reasonable? Every time we talked about this 1 here. This is the only situation in which 1 would exercise any real power. Right? 7 and 4 and 1. If he's on that team, he's making them win. And if he drops out, they will lose. So that's real power. So only when you're circled do you exercise real power, make any real difference in the outcome of anything. So every time we've circled something, all those are times when power is exercised, right? So, and these are all the possible scenarios, we listed them all out, when teams would win. So therefore, we're considering by doing it this way, we're considering every possible time when someone would make a difference, exercise real power. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times power is exercised. Right? There's 12 different times when power is exercised. Well, how do you figure out people's power then? Like their percentage of the power. You just find out what part of those 12 is theirs. So what's the power of player 1? Player 1 is the 10. This is player 1 here, the 10. So what's player 1's power? Well, how many times out of those 12 times power was exercised, how many times was it done by the 10? 1, 2, 3, 4, 5. 5 out of the 12 times that power was exercised, it was exercised by player 1. He's got 5/12 of the power. 5/12 of the different situations in which real power could be exercised, it's him doing it. He has 5/12 of the power. Does that make sense? Divide that in your calculator. Somebody get that? I have no, I should have brought my calculator. Somebody have 5 divided by 12, and we'll get a percentage. 0.416, thank you. I don't know if they want you to round to 2 places or whatever. Let's go on to player 2. Player 2. What's the power of player 2 then? Player 2 is the 7 here. 1, 2, 3. Looks like 3. So 3 out of the 12 times that real power was exercised, it was done by player 2. That's 1/4. I know that one, 0.25, right? Quarter, 1/4, 0.25. I don't know if math, they might want you to do a reduce. I think they want fractions. I don't know. They'll tell you if they want fractions, you would say 1/4. If they want decimals, you'd say 0.25, like that. Test is multiple choice, so you just grab the one that's the same as what you have. So shall we go on with player 3? This making sense? Player 3. What's player 3's real power? Player 3 is the number 4 there. So 1, 2, 3, 3 out of 12, which is 1/4, which is 0.25. So notice player 3 has just as much power as player 2, even though it's a 4 compared to a 7. In this system, it's still equal power, just because of the way the numbers play out, huh? Which is a little surprising. That's what I mean. It's not always what you might think. That's why we need math to calculate this, because it's not obvious. Finally, player 4, which is the 1. And there's only one time. Yeah, one time out of the 12. And so we have, what's 1 divided by 12? 0.06555 or something. Anybody got it? 1 divided by 12?
0.0833.
Oh, okay. 0.083. Thank you. There we go. We're done with the problem. That's the actual power. Player 1 has 41.6% of the power. You turn them into percentages. You know, I'm not going to fiddle with them anymore. Percentages, decimals, fractions, whatever. So player 1 has 41% of the power, 41.6. Player 2 has 25%. Player 3 has 25%. And player 4 has 8.3% of the power, because he has 1/12 of the power, because 1 out of the 12 times real power was exercised, it would be by player 4. So there we go. That's called Bahnhof power. Bahnhof power. Bahnhof was actually not a math person. He was a lawyer, an attorney. And he was in New York. Where was it? I don't know, 1960s? Yeah, I think it was the 1960s in New York. Bahnhof was an attorney. And he did this work for New York City. Let me see if I can find it. No, it's not there. Yeah, I don't know. I'm not going to find it. But anyway, I'll just tell you the gist of it. He, for New York City, they had different counties that had different amounts of voting. That's right. I have it in my notes here. There it is. Yeah. Anyway, so, and in the situation, they had different counties. This was 1964. In Nassau County Board in New York had Hempstead, Hempstead number 2, Oyster Bay, North Hempstead, Long Beach, and Glen Cove. These were areas in one county in New York. Anyway, long story short, they all had different amounts of voting. So when they would vote on something for the county, like what we're going to do with taxes, or what this county's going to do with all the people, the realtors, with the land, how they're going to break up the land in their county, on and on. Any decision that county would make in New York in the 1960s there, the different parts of that county had weights they had a weighted voting system. So the different districts would put forward their votes. Well, it turned out that Bahnhof, as an attorney, looked at the weights, the numbers. Nobody had done this kind of calculation before. And he went through all the math, and he showed that North Hempstead, which had 21 votes in that system, was actually a dummy. He wrote up an article in the newspaper. It was the New York Times or something like that, and published it. And people followed the math, and they were shocked, and there was lawsuits everywhere because North Hempstead realized for the first time that they were a big dummy in the decisions. It didn't matter what they wanted to do with taxes or with the land or with, all the proprietors, the people that sell stuff. It mattered not. Their vote never made a difference. That's where it all came about. Bahnhof created this whole system of determining real power in a weighted voting system. So math came in to help people learn what real power they really have or lack thereof. Make sense how we do that? That's the big deal. So we'll do that a couple more times. That's the whole calculation right there. That's the whole thing. Everybody see how we did that? So we list out all the winning teams, and then it's kind of tedious. You got to go through player by player asking, if he doesn't come, do they lose? If he doesn't come, who's critical? Circle all the critical times, 12 critical times. The denominator is going to be 12 for all the fractions, and then just give them the number of times out of 12 that they exercised real power. That's their percentage. That really is, isn't it? That's their portion. That's their part of the real power. And that makes a difference in society. People want to know. People want to know if they have real power or they don't. Well, I mean, maybe they don't want to know, but I think they do. Yeah?
When you were doing the two-player, why didn't you choose like 4 and 1 or 7?
Good question. Anybody know? Why didn't I choose 4 and 1 or 7 and 2, 7 and 4? They're not winners.
So you just choose what you...
Yeah, this was all winning coalitions. Yeah, right. Because these are not winning teams. Therefore, they're not even going to win, so nobody could be critical. They're not even winning, so nobody's making a winning difference. Yeah, good question. You're only listing the winning teams, the teams that add up to 12 or more. So that's why I didn't list any other ones. Good question. Other questions on that one? That makes sense? So we just got to practice this a couple times, huh? This is just a little bit tedious. All right, so there's 2-1 right now. Here, let me stop that.